everybody. So here's the beginning of chapter 6. And we start out talking about polygons starting on Tuesday, maybe Wednesday. We'll have an activity that lasts a couple days to help explain some things. And so here's a picture. This is a picture of a polygon. Notice that in a polygon, the sides are made up of segments. The corners are called the vertices. And if you draw a segment from one vertex across to a non-consecutive vertex, one that's not right next to it, it's called a diagonal. Okay, now you can name it by the number of sides, and I get asked this a lot. Do we have to memorize these? And the answer is no, but a lot of them you probably already know. Triangle, right? Quadrilateral means 4. Probably know pentagon and hexagon. Most students, heptagon is one that's new. Heptagon is 7 sides. Octagon, if you're a MMA fan, you know what the octagon is. Nonagon's kind of new for students. Decagon, decade means 10. And dodecagon is one that's very obscure that students don't know real well. And if you look at the bottom, engon is another way to describe a polygon. So instead of saying a heptagon, for example, you could say a 7gon. It's a closed figure formed by 3 or more segments that intersect only at their endpoints, so they can't cross. So if you take a look at this one, the question is it a polygon? If it is, tell by the number of sides. Well, notice they're all segments and they only intersect at their endpoints 1, 2, 3, 4, 5, 6. And so it's a polygon, and 6 is a hexagon. Next one, tell whether it's a polygon. There are only segments that intersect their endpoints. 1, 2, 3, 4, 5, 6, 7. So yes, it is a polygon. It's a heptagon because 7 sides is a heptagon. Or remember, you could say 7gon, and the one before you could have said 6gon. This one's not a polygon because they're not segments. I don't care if they intersect at their endpoints. They have to be segments, and these are curved lines, not a polygon. This one, notice the segments don't meet up. They have to meet. They can't cross like this, and they can't not end at a vertex. So this is not a polygon. This one is a polygon. I'm going to struggle with the number of sides. Let me try 1, 2, 3, 4, 5, 6, 7, 8, 9. So nonagon, and it is a polygon. This one's not. See the curved end right here? So not a polygon. All right. Next thing's key, and this is going to lead into our activity that we're going to be doing on Tuesday or Wednesday, what a regular polygon is. A regular polygon is one that's both equilateral and equiangular, which means all the sides have the same length and all the angles have the same measure. If it's not regular, it's called irregular. Concave and convex are another way to describe 2 types of polygons. And let me just give you a picture of an example. The one on the left is called concave and one on the right is called convex. And here's how some students choose to remember it. I like these both. Concave has the word cave in it, like caved in. And so notice this side is kind of caved in and this one's not. Some students remember it that way. Here's a second example. Some students use this example. I threw this one out years and years ago, and some students liked it. If you stretched a relatively small rubber band around the outside of these, the rubber band would fit the convex one pretty snug. The rubber band would fit snug here, but it would go right over this section right here. The rubber band wouldn't know to bend in here. Okay, and so there'd be a little gap. And if there's a gap when you stretch a rubber band on the outside, it's concave. Notice the word gap and concave both have the letter A in it. So that's a way that you could remember that. Okay, regular or irregular. So this one is irregular because if you notice, although the sides are the same, these angles are different. Concave or convex. This one's called convex because it's not caved in and the rubber band fits snug. Learn one of those. I'm going to use the caved in definition. So irregular, convex. Next one. Notice the sides are not the same length. Irregular. All the angles look like they're almost the same, but it doesn't really matter at this point, right? So this is irregular. Actually, this angle right here would be the same. And it's concave because this side or this part of the figure is caved in. Okay, this one, notice all the sides are the same, all the angles are the same, so it's regular, and it is convex. Almost done. Regular, convex. All sides the same in angles, and it's not caved in. This one is definitely irregular because the sides are not the same and the angles are not the same. And it's caved in right here. So irregular concave. And that's it. Thanks for listening.